Okay, let's start. So we are looking at the 30th March. 30th March 2023 paper. Okay? So, you ready? This is the March 30th 2023. This is last semester. Okay? So let's go through it. So, question 1. Right? Okay, let's see if there's any specific instructions you need to follow here. Answers must be rounded off to 3 decimal places. Answer to the recording. Okay, yeah, fine. The only thing you need to know from the instructions was 3 decimal places. Okay? So let's start question 1. So, draw the graphs or the two graphs of y is equal to plus x cubed and y is equal to minus x cubed on the same set of axes. So the first thing we need to figure out when we're looking at this is, okay, so the first question, the question 1 is on graphs. Eh? What type of graph firstly is y is equal to x cubed? It's a cubic function. Okay? But we don't have that bx squared plus cx plus d. It's just ax squared. And remember when we did the last thing we did in differentiation, limits and differentiation, when we were solving for cubic functions, showed you 2 types of graphs. Remember I told you when we substituted values for 0, everything was coming to 0. When we tried to do the first derivative, still coming to 0. The point is it's still 0. Right? So how would the graph have looked? So, if this is your set of axes, right? This is your y, that's your x. How would you have drawn the y is equal to plus x cubed? What theory would you have remembered? Which quadrants would it fall through?
First and
Third, because it's a positive value, right? So this graph would have looked like, well, make sure it passes through 0. So this is y is equal to x cubed, positive x cubed, right? And with negative x cubed, second and fourth. So it looks says y is equal to negative x cubed. That's your answer for 6 months.
6 months.
6 months.
So you don't have to like work out anything like doesn't we actually.
For this one, yeah, we don't. This one, remember, for this one, we don't do it. You won't work anything. Because whenever you work, it all comes to 0.
Okay.
So this one, yeah, remember, actually, just remember the shape of the graph. How it look. Cubic function. If there's no b, c, and e value, you just draw it through 0. But you must remember how the positive would look and how the negative would look.
But you could, in a way.
Let me draw
But
it.
you could actually make it realistic.
Don't overthink it.
No, because what I did was
If you work it out, you're gonna get zeros.
You're still gonna get zeros.
X and Y and then it's minus 0 plus 0 is still 0.
No, yeah. So what I did was, I said, for instance, I made x 1, right? 1 cubed is 1. So I made the y was 1, x was 1, right?
Yeah.
Then when I made it, like, say, for instance,
Oh, you substitute. Remember you asked me, I told you
Yeah.
substitute the values.
no, I just did it just so you make it
You
more
can see,
accurate.
yeah.
Yeah, I did my own little thing, and then I could put a 2 cube would have been, so 2, and then I made it with the y would have been 8. So I made it 8, and then basically, so I just did my own.
Then you can draw it. Okay, why I drew it in 2 different colors was I didn't want you to get, remember the black rating, I don't want you to get confused with how 2 parameters would look, right?
Yeah.
So I drew it with 2 colors so you can remember the differences for the positive and negative. Okay, 1.2. 1.2, I don't like the way they number these questions because if you look at it, right, normally when you get 1.2 and they give you it's like some theory of it and then you go on to 1.2.1, right? But 1.2's question is draw the graph of x squared plus y squared equal to 25 and you can see 4 marks at the end. So sometimes what tends to happen is that people just move on to 1.2.1 without answering that part where it says draw the graph. Okay, because you're just thinking it's a sub question on it. Okay, so let's draw the graph. They give you x squared plus y squared equal to 25. Looking at this, what type of graph is it? It's a circle, right? Because circle's formula is x squared plus y squared equal to r squared. This here 25 is 5 squared. Okay? So to draw a graph you need your intercepts. So for your y-intercept you're going to let x equal to 0. So you're going to end up with 0 squared plus y squared is equal to 25. Y will be equal to plus minus the square root of 25. So y is equal to plus minus 5, right? So your coordinates for y is 0 and positive 5 and 0 and negative 5. So you're going to do the same thing for x-intercepts. So for your x-intercept, you're going to let y equal to 0. So this is going to become x squared plus 0 squared is equal to 25. You're going to get x squared equal to 25 and then x is equal to the square root of plus minus 25. X is equal to plus minus 5. So its coordinates are 5 and 0 and minus 5 and 0. So when you're drawing the graph of this, it's going to look like okay, so just say 5 is there, minus 5 is here, 5 minus 5, right? It's all our coordinates. Okay, so this was your y coordinate of 0 and 5, this was the other y coordinate of 0 and minus 5, x coordinate of 0 and 5, x coordinate of, minus 5 and 0, 5 and 0, and this was your other x coordinate of minus 5 and 0. So what do you need to do now? Draw the graph, right? So all you do is you connect. Okay, mine is not necessarily to scale here, but anyway, this is it. That's your y, your x-axis. So this is x plus y squared is equal to 25. It's a circle.
You give a max
for that 5, yeah. Because remember that you know where the
That's to show that.
yeah. This from looking at this, you don't have to even do this calculation because you know that r squared, right, is equal to 25. So r is equal to 25. It's a circle. It's the radius. So at that center point, it's going to go through 5 units around. So yeah.
But you need to do it for marks or
No, they don't give you marks for this. They give you a marks when you're showing the 5, the 5 minus 5. I'm just showing you what's one. You'll know where you got the 5 from.
now what happened because the first one is 6 and this one's 4. I'm like, yeah.
Yeah, you just need to show
Show
the
this.
yeah. You understand this, right? Okay. Then they ask you to, is the graph x squared plus y squared a function or a relation? What's a relation?
More than
Right? If for every value of x, you get more than one y value. And then a function is when you have one x value, you get one y value. So if I were to take an x value of 2, I'm going to get 2 y values, right? If my x was equal to 2, it's going to go up. So if my 2 was here, it's going to go up to the y-axis and get a y value, right? It's going to also come down and get a y value. So this graph is a relation graph. Then they ask you, is the graph symmetrical about the y-axis? Is it? It's a circle, right? Circles will always be symmetrical. Okay? So your answer is yes. Then they ask you, make a neat sketch of two functions of y is equal to log ex and x is equal to log ey on the same set of axes. So for 1.3, y is equal to log ex and x is equal to log ey. Now, when we did exponential and logarithmic graphs, what did we do? What major? Right? So first thing we need to do is convert that logarithm to exponential form. Okay? And remember what I told you, log base of your answer is equal to the index. If you look at this, log base, so your base is e. Answer is x and the index for the base will be y. Okay? So on this end here, it's going to be e to the x is equal to y. Now we need to solve for our points. You remember how the shape of a log graph looks?
Yes.
How it looks? Comes like a curve, right? But if it cuts the y-axis, it's never gonna cut the x-axis. If it cuts the x-axis, it's never gonna cut the y-axis. So for here, we want our intercepts, right? So we'll say y-intercept, let x equal to 0. So this will be e to the y is equal to 0. Now to solve for y, we have to use logs again, right? Because y is equal to log e to the 0, which is undefined. Cool. Then we say x-intercept, let y equal to 0. So you're going to end up with e to the power 0 is equal to x, right? 1 is equal to x. So one coordinate we have is 1 and 0. Everybody understands?
Yes.
Okay? Now, remember with this here, if your graph was this, okay, just say if this was your graph, right? And 1 is here, right? Your graph could either look like that or it could look like that, right? But how do you know which one of those it is? You need one more point. So what you'll say, you look at the one where you actually got an answer for. So we actually got answers for x-intercept. So we're going to say let y equal to 1. So you get e to the power 1 is equal to x, and you get 2 points. That's it.
2.7.
You know it's 2.7. You get 2.718 equal to x. So we got another x coordinate of 2.718 and 0. Right? So we know we can plot that. Fine. We're done with it. This side. So for your y-intercept, let x equal to 0. So you're going to end up with e to the power 0 is equal to y. 1 is equal to y. So we have a coordinate of 0 and 1. Then you say for your x-intercept, let y equal to 0. You're going to get that e to the x is equal to 0, and then this here is going to come out to undefined. So we need another point. Look at the one that actually gave you an answer, and that's the one you would choose, right? This one actually gave us an answer. So we're going to say here let x equal to 1. So you're going to get e to the 1 is equal to y, and then this graph's coordinate would have this would be 2.718 equal to y, and then you have 1 and 2.718. So now for both graphs we got two coordinates, we can plot it, right? So to plot it, this is your axis. Okay, so this is 1 and 0. That's 1. This is 1 and 0. That's 0 and 1. Right? We know. Okay, let's look at this one. So this one, the one coordinate is 1 and 0, which is here. Right? Other point is 2.718 and 1. So if you look at it, it's going to be maybe say there. Right? So you know now how your graph is going to look, because it has to come through those points. You draw it as close to this y-axis as possible, and then you draw it again. Right? So which graph is this? This is y is equal to log e x. All with me.
Yeah.
Right. Then for your other one, this one here, one coordinate is 0 and 1, which is here. Your other coordinate is 1 and 2.718. So 1 we said is here, and say 2.718 is there. So when you're drawing the curve, it's going to come as close to the x-axis as possible, and then you're going to go like that. And then this here is x is equal to log of e y. This is your y-axis, this is your x-axis. Does everybody understand this?
Yes.
Okay? That was your graphs question in last time, Mr. Speaker.
That's everything we covered.
Everything. Looking at nothing you can say we didn't do. Right? You want to take it on?
Yes.
Do that. Okay, so question 2, they ask you to simplify and express the answer in rectangular form if you are given z is equal to minus 4 minus j3 cubed, right? They want you to simplify it and give your answer in the rectangular form. Now remember yesterday I told you that when you are multiplying complex numbers or dividing, it's better to be in which form? Polar form. And when you're adding and subtracting, it's better to have it in rectangular form. So instead of you doing minus 4 minus 3 j3 times minus 4 minus j3 times minus 4 minus j3, convert it to polar form, right? So you're going to convert this inside portion to polar form. Okay? So you're going to say your r value will be equal to what? How do you get your r? A squared plus that imaginary number, the b squared, right? So your a is minus 4 squared plus your b is minus 3. Minus 3 squared, which gives you what? It gives you the square root of 25, which is 5. Your r value is 5. That. Then you want to get your angle. Now remember something, if you look at the graph of this, remember this is, that's your imaginary numbers, that's your real numbers. Okay? Your real number is minus 4 and your imaginary number is minus 3. So the line you're going to get is 10. So when you're working on tan of the angle you're working on it here. But what do you need to do to the angle? You need to add 180 because of that. So whatever number you work on here, you need to add 180. Okay, so here firstly, it's going to be 10 to the minus 1 of your imaginary part over the real part, or your y-axis over your x-axis. So it's going to be minus 3 over minus 4. All with me?
Yes.
Okay, so what number you get here? 870 degrees, right? Plus 180. So you're going to get 216.870 degrees. So in the polar form, this here is 5 and 216.870. So now Z is equal to this here cubed, right? Remember, this should be 5 times 3 and your angle is 216.870 plus 216 times 870 plus 216 times 870. You could have just said times 3, but I don't want to write that there because you're going to think for all things with multiplication, you just multiply, right? It's not that. Here, you add the angles. Okay? So, okay, this here would be 125. No, sorry, you don't multiply by 3. You cube it. Right? Okay.
Yeah.
Yeah. Okay. Which is still yeah, it's 5 times 5 times 5. It's not 5 times 3. Sorry about that. It will be 5 times 5 times. Must I say 5 times 5 times 5 times 5 times 5.
This is cube.
It's fine, right?
That you multiply to each one to add on some chance. And you
Yeah.
multiply.
Okay. So this is 125, and then this angle is
650.61.
650.61 degrees. But that's in polar form. You want your answer in rectangular form. Okay? So this here would be 125 into, how you get it to rectangular form? Yeah, CIS, right? So cos of the angle plus your imaginary part sine of 650.61. So remember, it's going to be 125 cos of 650, 125 sine of 650.
Yes.
And what you get?
The first one is 44.
44, right? Yeah, so 5, I think it's 44.000. Yeah, so that's fine. And then the next one, you're going to end up with minus.
116.
Yeah, it's going to be minus. I think it comes 117 if you round it up.
Yeah.
It will come 117. That's your answer. Do you understand what I did? Okay?
Yes.
Okay. So all I did was I converted it to polar form. I did how we would do polar form for multiplication, because this is, remember, it's 5 times 5 times 5, which is the same as 5 cubed. And then I just converted it back. Very easy to convert from rectangular to polar. I mean, from polar to rectangular. You just use cos and sine. Okay? That was that.
Can we leave it in rectangular form and do it together?
Yeah. You can multiply out but sometimes you end up with too many terms, and then when your j squared, remember, is minus 1. So when you multiply minus 1 times the sign, you end up with the whatever sign was outside. Some people miss out that other sign. Then you end up coming with it off. Okay? Just another thing I want to show you, right? You know how to use or how to do complex numbers on your calculator. Okay, take out your calculator. Just this here, what I'm showing you is a method to double check your answer. This is not a method for you to answer your test. This is how you answer your question. If you have to see whether your answer is right, use this method. Okay, this is all just down here, teaching you so you know how to do it. Right? So press the mode button. Mode. Right? See the one that says complex? Right. 2. Press complex. So now you see on your screen at the top it says complex. So now your calculator is in complex mode. Okay? So you're gonna open a bracket. You're gonna put minus 4, minus, then you're gonna press shift, right? And you can see where they have I on your calculator, it's above where the ENG button is.
Yeah.
Right? Can you see? So shift that button, your calculator came up with the I. And then you're gonna put 3. So when you calculate, the 3 is supposed to be before the I. So write the 3 before the I. Write minus 3j. Or minus 3i. Minus 3i. Okay? Close the bracket and then cube it. So yeah.
But can you put the I first?
When you're doing it in your calculator, it'll tell you a syntax error. Because it's supposed to be written as, remember the formula is a plus b I. So the b term is first. The calculator knows it as the b term first. I don't know why they write it, because I also know it as minus 4 minus 3j, not minus 4 minus j3, because sometimes you forget about the minus sign when you take in the value of b.
We never taught this before.
Yeah?
Here's why.
I never taught you complex numbers. Right? And if you look at the number that they got, they came to that. Remember, you think if you're doing that in the test and you're gonna get full marks, you are absolutely not going
And
to
what
get
fun you
40.
can do, you can
But it's a
go into
good way
the
to-
calculator to know what answer you need to.
But you know, it's nice to know because you can either use it as you know what you're working towards,
Yeah.
or you can use it as to double check if your answer is correct. And if you look at it, your answer is correct. Okay? Fine. Okay, so you can do the complex number.
But the memo doesn't get an answer.
The memo doesn't have this answer because people are stupid when they do the angle, right? When they did the angle, I don't have the number right here. They went and did the angle, but they subtracted 36.87, which doesn't make sense. From the graph, you can see that if you draw the path, it's found here. How can you subtract 180 because it's going to end up here? And if you put the answer from what the calculator gives you and what they gave you, it's wrong. Right? So this is the method to follow for that. Right? Okay, so that's one way of double checking your answer, right? Then, and remember after you do all this, please clear your calculator.
How do we do it again?
Shift
59.
9,
Shift 9,
3, AC, and then that.
Okay, fine.
Right? They give you, once you press shift 9, they tell you clear all, just 3, and then press AC and you go back to your research. So anytime you change any mode on your
But it's
calculator,
amount.
hmm?
It stands in amount.
No, the complex number should be out.
Okay.
Shift 9, 3, equals to.
No, they had it. See what they had 4 over 3, not 3 over 4.
Yeah, doesn't make sense. Because
Yeah.
if you look at where it's found, and they're even saying over here that tan of y, your y-axis is your imaginary part.
Yeah.
So how can you take -4 because -4 is your real part, and on a complex numbers graph, your real part is your x-axis. Your imaginary your real part is your x-axis. Your imaginary part is your y-axis. They're telling you it's tan of y over x, but they went and put it as tan of x over y. Doesn't make sense.
How many people fail because of that?
Probably. But I don't know why these examiners when they make it they make it the night before they're gonna mark or something. Okay, guys, I'll give you a time to take it down. Let me go on to the next one, right? So the next one they ask you to simplify 30 degrees times 4 CIS 40 degrees all over 6 cos 20 degrees plus I sine 20 degrees. Is this a difficult one? It's not, right? Because what they did was, they got the 3 different types of ways you could write polar form. Remember, we could write it as a argument and modulus method, which is this first one. Then this is your argument, that's your modulus, right? Then they wrote in that cis method. The cis is basically cos I sine. It's just abbreviated to be that. So all of those 3 things mean the same thing. Okay? So if you have to rewrite it, 30 and 30 degrees times 4 40 degrees. I'm writing it as an argument modulus method, right? 20 degrees. All the same thing. Right? So what you do, on the top you multiply, so you end up with 3 times 4 and 30 plus 40 over 6 and 20. So then you're left with 12 and 70 over 6 and 20, which is 12 over 6 and 70 minus 20, which is 2 and easy. I think even this one too you can also put in your calculator. You wanna know how? Okay, more?
But it's actually really like
That one is straightforward, yeah.
No, but once you convert all to the same, it's actually really
It's the normal method for right? So mode, complex numbers. Yeah, so you're calculating complex mode. Press the fraction button, now you're on top of the fraction. Right? You're gonna press 3 and then you're gonna press shift off. You see the button that has this here, right?
Yeah.
Above it, you see in a small thing above it, it's that. Okay? So shift that button. That sign should appear. Yeah. So what that sign basically represents is, you see that dash thing I draw?
Yeah.
Right. So you're gonna press 30. Actually, you should have kept the whole thing in brackets. Like keep the 3 and the 30 in brackets, right? Then next to that bracket, open up another bracket, put 4 and the same thing at 40. And then go down, and then you're gonna put 6 brackets, 6, and that thing. And then equal to
He did it.
only probably convert the whole thing. Take it the whole thing. Well, they give you an answer in rectangular form. Okay, they gave you your answer in rectangular form. I want it in polar form. Ah. Yeah. Okay, you gave your answer, right? You got your answer with you? Right? They gave it to you in rectangular form. You want to view it in polar form. Shift 2.
So I must say answer then shift 2.
Yeah, answer, you got your answer, right? They give you a whole lot of numbers, 1.5, blah, 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 and they got an arrow going down. You ever see? Yeah, right? So you're going to press Shift 2. Now Shift 2 will give you some options for some of your complex number things. So at the top I think it says Argand, diagrams,
Yeah.
and then they give you R, the dash with the angle, that's telling you convert to polar form. So you're going to press 3 and equals to. And then what you get? Okay, so your one. So this is your one, right? Polar form, this is converting back into a rectangular form, that's the conjugate, that will give you your argument values. So press 3, so that same answer is reconverted to polar form. 2. Huh? Okay, so yes, obviously this one.
Then to convert this to press shift and switch to complex.
But why does it say this?
And now we're going to list. Punching is big, yeah. It's not required.
Guys, please, right? Don't make me regret showing you all this, right? Because, no, I'm being serious, because don't forget your method. I told you all, I'm emphasizing, I'm on video telling you all this. That is not how you'll answer the question. These methods for calculators will be used to double check your answers, not to solve and write that there and think you're going to get full marks. This question here was 4 marks. The other question was 4 marks. If you just write that and that and that and that, you get 2 marks, 2 out of 8.
Jeez.
Right? Not difficult questions.
And maybe you rather.
Very easy to mess it up, right? But while you're doing this, is you know what you're working towards. Okay? So when you know you're working towards, you get it, you know, guaranteed I've got 8 marks already. So now we're sitting on 28 marks. Because we got full marks for the graphs. We got full marks for this because we know we got it. Okay? Then, let's do the next one. Now this next question, a lot of people had issues with this because they felt like they didn't know what it was. Right? They gave you, so this is determinants, right? 2.3. 1 over x, 3 over x, 2 over x, plus 2 over y. This is what they gave you. They want you to solve for x using Cramer's rule. Looking at this, how would you solve it?
So for it.
This is determinants.
Determinants.
Right.
So substitute.
Okay, that's what you eventually do. So when you're writing the determinant of this, how would you write it?
So the first one, 1 over x would be 1 over 1x, so it's 1 times x.
First we're gonna do
Right,
the
so it's
outside.
gonna be x and 1x.
What you did that?
1 over x.
Remember when we're drawing determinants, right? If we had 3x plus 2y equal to 4, right? And then we had 6x plus 8y equal to 4. And I tell you what, do the determinant. Draw on video, you got me buffering over here. Yes, it's okay. So you would take, to make the determinant, you would take these coefficients in front of it, right? So you'd have said 3, 6, 2, 8, right?
Yes.
How would you make that for this?
Do the same thing.
So how you do the same thing?
One.
This is testing application. That's why people got stuck, because they're stuck on one method of being so used to seeing one type of question
And
that when you see something else, they go, oh my god, what is this?
So 1 over x is equivalent.
So
to
what's your
1
constants?
1,
1.
Kaya, you're saying 1 over x is?
1.
is 1x.
Is x
One
minus
It's x to the power negative 1.
to the negative 1.
Or, remember, it is x to the power negative 1, right? Or it's 1 times 1 over x, right?
Okay.
Same thing over there, it's 2 times 1 over y plus 1 times 1 over z. The next one is 3 times 1 over x minus 4 times 1 over y and so on. You see what I'm doing? Okay?
Yeah.
So, when you're solving for x, instead of doing the determinant of x, what you actually got to do?
Simplify first.
No, what determinant you'll be solving for?
The first one was 1.
Okay, so you see over here, right? If I asked you to solve for the determinant of x, you would have substituted 4, and using Kramer's rule, you would have said x is equal to dx over d, right? Now, if you're solving for x here, and if you're working out the determinants for x, you're actually working out the determinants of 1 over x. It's not x, it's 1 over x, right? It's 1 over x. So when you're using Kramer's rule, you're actually solving for 1 over x, d of 1 over x over d. Do you understand? It's the exact same thing as this, it's just that x is 1 over.
X.
Okay.
Okay? So they could do that in a lot of circumstances. If they had 3x squared, right? 3x squared plus 2y squared plus 1z squared. All of these here were squared. When you're doing a determinant, you're solving for the determinant of x squared. And when you use Kramer's rule, you're saying x squared is equal to d of x squared over d. You understand? So don't only be used to just seeing x plus y plus z. You could have x squared plus y squared plus z squared equal to, and they ask you to solve for x. Right? Because people suddenly they don't know whether to take out numbers, whether to do the x to the minus 1, how to play around with it, right? Because they're so used to just seeing x that they think that's the only thing you would see. Okay? So for this here, remember, your constants that you would pull out is 1, 2, 1, right? 3 minus 4 minus 2. 2, 5 minus 2 equal to 2, 1, and 3.
Okay.
Okay? It's now remember you're not dealing with x, you're dealing with 1 over x, 1 over y, 1 over z. This is still the same because it's just your coefficients at the end. Yes? So now that you have this, solve exactly like how you normally would solve this question. Right? Your determinant is equal to 1, 3, 2, 2 minus 4 and 5, 1 minus 2 and minus 2. Yeah?
Yeah.
Okay, so let's choose row 1. So when you're solving for this, you take your first number, multiply it by minus 1 to the power, the row plus the column. 1 is found in row 1, column 1. You all understand what I'm saying, right?
Yeah.
Okay, so this is 1 plus 1, and then you multiply by the minor, right? So if you block out row 1 and column 1, you're left with minus 4, minus 2, 5 and minus 2. So you're left with minus 4, 5, minus 2, minus 2, plus second number, which is 2, times minus 1 to the power, which row and column is it?
2 plus the
It's in row 1, column 2. So 1 plus 2. If you block out that row and column, what numbers are you left with? You're left with 3,
3 and
2, minus 2 and minus 2. Right? Plus. Last number is 1 multiplied by minus 1 to the power, which row and column is it? 1 plus 3. It's in row 1, column 3. Okay? 1 plus 3. If you block out that row and column, you're left with 3, 2, minus 4 and 5. Which is 3, 2, minus 4 and 5. So now if you work it out, right?
3, 2, underneath, 2 underneath.
Oh. Okay. So this is 2, yeah?
Yeah.
Okay, right. Minus 1 to the power 1 plus 1 is minus 1 squared, which is positive. Times 1 is 1, right? So you have 1 into minus 4 times minus 2,
8 minus
5 times minus 2. So remember before you get it, it's going to be 8 minus whatever this is, right? So 5 times minus 2 is minus 10. Minus 10 is plus 10. Plus minus 1 to the power 1 plus 3 is minus 1 cubed. Minus 1 cubed is negative 1 times 2
minus 2
is minus 2. So it's minus 2 into 3 times minus 2
minus 6
minus 2 and 2 minus 4. But the minus sign plus 4. Right? Plus minus 1 to the power 4 is 1. Right? Times 1 is 1. And then you get 3 times 5, which is 15 minus 4 and 2 minus 8 with the minus sign plus 8. Right? So here you're going to get 8 plus 10 minus 2 and minus 6 is positive 12 minus 8 plus 15 plus 8. Okay, 80 times 20, 30, 22, 37, 45. Right? Then you put it 45, right? So your determinant is 45. Guys, everybody is with me.
Yeah.
Anybody confused about what I'm doing so far?
No.
Okay. So now we got our determinant, right? Because Cramer's rule would be 1 over x is equal to the determinant of 1 over x over determinant d. Right? So now we are solving for what? We are solving for the determinant of 1 over x. We're solving for the determinant of that column, okay, where x was. So it's the determinant of 1 over x. All still with me. So what we would do, we would substitute these values here for that 1 over x column. So it's going to be 2, 1 and 3, 2 minus 4 and 5, 1 minus 2 and minus 2. Right? So this here is going to come to, your first number is, I'm choosing this one, is 2 times minus 1 to the power, which row and column?
1 plus
1 plus 1. If you block out this row and this column, you're left with
minus 4 plus minus 2 minus 2.
Right. Plus your second number is 2 times minus 1 to the power.
1 plus 2.
Block out that row and column you left with.
1 and 3. 2 minus 2 minus 2.
Right. Plus your third number is 1 times minus 1 to the power, your row and column.
1
Block out that row and column.
3 minus 4 5.
Okay.
Lapping the roof.
Hmm?
Lapping the roof.
Minus 1 to the power 1 plus 1 is minus 1 squared, which is positive 1. Times 2, positive 2. Minus 4 and minus 2,
8.
8.
Plus this.
Right? Minus, so minus 2 and 10 is minus 10. Times the negative sign will make it positive 10. When you're doing it, you will write minus 8, minus 10. So you'll see it first and then you put positive. Because then you'll say minus 8 here and then you'll just carry on with minus 8. So you'll say 8, 9 and then you mess up the calculation. You put the extra line if you need to. Because it's a quick, I'm doing it slowly with you, but when you're writing it, it's quick, right? Plus, plus, right? Minus 1 to the power 3 is minus 1. Times 2 is minus 2. Into 1 and minus 2, minus 2. 3 and minus 2, minus 6. Minus 6 and my negative sign makes it positive 6. Minus 1 to the 4 is 1. Times 1 is 1. Into 1 times 5, minus 3 and negative 4, negative 12. Times the negative sign, plus 12. Then you left with 2 and 8 is 16, plus 20, minus 2 and minus 4 is plus 4, minus 2 and 6, minus 12, plus 5, plus 12. Then you get 6, 48, 45. Right? And you put it in the calculator together, right? Cramer's rule will state that 1 over x is equal to dx over d. Though d of 1 over x. Right? Because now the column is not called x, the column is called 1 over x. So look at it in terms of the columns of what would have been in that spot, right? Then 1 over x is going to be equal to d of 1 over x is 45 over 45. So 1 over x is equal to 1. So what would x be equal to? 1, right? Because if you cross multiply, x times 1 is equal to 1, it's still x, right? So x is equal to 1. But this is not necessary. If your answer, I'm just saying for example, right? If you ended up with 1 over x is equal to 90 over 45, right? You're going to get 1 over x is equal to 2. You solve for x because the question asked you what is the value of x, not what is the value of 1 over x. So you would have had 1 is equal to 2x because you cross multiply. And x would have been equal to 1 over 2. That's the value of x. Okay? It's just that this one here, because it came out to 1, you wouldn't understand what I'm talking about. But if they ask you, that's how you would do it. Okay? Do you understand how this question was done? In the exam, would you have got stuck?
Yes.
Oh, sure.
That's why the sponsor papers are important for all these variations of questions. Because they know what students get comfortable with and then they know how to catch you.
So you only use 1 over x when you're solving for x.
Hmm.
Last answer. That's why you only use 1 over x.
Yeah.
That's everything.
Because remember here we're doing the determinant of 1 over x. And then you carry on. Okay? So if they told you, remember, like I said, if they said 1x squared plus 2y squared plus plus z squared, right? You would have solved for the determinant of x squared. And then Cramer's rule would have said x squared is equal to dx squared over d. It's always that column over the determinant of the entire thing would give you whatever that column is. You understand what I'm saying, right?
I'm sorry to worry you. This sum, you can do it the same as 1 over 2 plus 2 over 3, like the other fraction that you may be given if it's not over x.
Like if it was 1 over 2
Yes.
x.
Yeah.
Yeah, so what you do, this is the same as saying 1 over 2 times 1 over x.
Oh.
Right? And this would be a constant. So this would have been 1 over 2 here.
Okay.
And then you'd have still solved the same way. You'd have still solved for 1 over x. It's just different values.
Oh, okay.
Okay? So everybody you understand that, right? So just don't get confused when you see that for Kramer's rule. But this one they caught everybody off guard with that. Because people were trying to figure out whether they just typed it wrong. They just tried to figure out whether they typed it wrong, what was the issue.
We never had anything like this before.
Yeah. But see, because that's what you're too used to doing one like this.
Yeah.
Because we're too used to saying Kramer's rule states that x is equal to dx over d, y is equal to. That's not exactly what Kramer's rule is. Kramer's rule is saying that that function is equal to the determinant of that function over the determinant of the whole set. That's what Kramer's rule is. So 1 over x is equal to the determinant of 1 over x over the determinant of the whole set. Okay? Let me do the last one, then you can take it down, right? They tell you for 2.4, given x plus 2y is equal to 4 and 5x plus 3y is equal to 1, determine the value of x and y using Kramer's rule. It's a 2 by 2. Right? Not bad. So, firstly, write out your determinants, right? It's 1, 5, 2, 3 equal to 4 and 1. Now, Kramer's for this here now, this would be x is equal to dx over d. Okay, so let's solve for d. d is equal to 1, 5, 2 and 3. This is a 2 by 2. So all you do is you just cross multiply and subtract, right? So this will come to 3 times 1 minus 10, which is minus 7. Yes? Then you substitute for your x. So dx is equal to 4, 1, 2 and 3. So 4 and 3 is 12 minus 2, which is because answer was different yesterday when I did it. I don't know this right, no? I don't know why I'm feeling like I didn't answer differently yesterday. Yeah. Okay, this is right, right? dy is equal to 1 and 5, 4 and 1. Cross multiply 1 minus 20, which is okay. So now x is equal to dx over x and y is equal to d of y over y, which is no, not y, it's d. Good work, I'm testing you.
X is d.
Yeah, even here too. Good, that's testing you to see. Right?
It's x plus 2y equals to minus 4.
That's the question.
Yeah.
But the question in the question paper is not that. The question in the question paper is x plus 2y is equal to 4.
I know, that's not.
That's why I don't know whether maybe last time they sent addendum to say that change question 2.4 to minus 4 or something. Because maybe I'm thinking I answered it by minus 4, but I realized the question is, can you see how much errors people make?
Yes.
God, it's frustrating me. Right, 10 over minus 7 is what? Or you can leave your answer like that. You can leave it as minus 10 over 7. Oh, but if you get it in decimal, what is it? Hmm? You can use it for what you get in decimals. 1 minus 1.4
29.
And then minus 19 over minus 7. 2 point something.
2.714.
714. Okay, but 2 by 2 is simple, right?
Yeah.
AD minus.
Just remember not to put the third order. So one.
Yeah, for 2 by 2 it's just cross multiply. Don't confuse yourself, right?
So there's no minus 1.
Yeah. That's only for third order because you have more than one number. Okay, so this was the complex numbers and determinant section. Only thing that could have caught you up here was this question here. Everything else you shouldn't have. But here when you look at it, you need to remember, you pull out the constants. So it will be 3 times 1 over x. So you know that columns now, instead of x, y, and z, you have 1 over x, 1 over y, 1 over z. Then you solve. But now you know the trick to it, so I don't think they'll be able to catch you. That's it?
As long as I don't put trick into this thing, it's
No, okay, that's okay. I can take it down. When I paused it.
Maybe it was the time you were writing.
Yes,
But that was before the start of question 3, isn't it?
No.
So there was 3.1 and 3.2.
Before I started question 3. Yeah.
Guys, please check the group. Question 3.1 and 3.2. We're now on 3.3. I'm not really saying the situation. Okay. Right. 2x and x is 2x squared. 2x and 1 is positive 2x. Minus 1 and x is minus x. So 2x minus x is x, positive x. Minus 1 and 1, minus 1. So it works, right? So here it will be 2 cos 2t, theta minus 1 times cos 2 theta plus 1 equal to 0. Then you'll say 2 cos 2 theta minus 1 is equal to 0 and cos 2 theta plus 1 is equal to 0. Cos 2 theta is equal to 1 over 2 and cos 2 theta is equal to minus 1. So normally what you'll do, get your reference angle and then this here cos is positive first and fourth, cos is negative in the second and third. And you'll set that's your values. And don't show to do here. What I want you to do is the general solution method. You would have done this in school, right? So hopefully I hope it comes back, right? It's the k times 360 method, right? So what you do, you'll get your reference angle. Okay? So your reference angle for shift cos half is 60 degrees. And then your reference angle here is 180 degrees. Okay? All still with me?
Yeah.
Okay. Wait. I haven't done this method in long. Let me write it like this, right? Okay, now let me write it like this way. So, this. Okay, let me write it like this. So, general solution once you come to this point, right? General solution would be your value of theta is equal to cos to the minus 1, or 2 theta is equal to cos to the minus 1 of half. That's how we got that 60, right? Okay. Same thing here. Your value of 2 theta is equal to cos to the minus 1 of minus 1. Right. Now with the general solution method, you take the positive and the negative value of this and you add k times 360 degrees. Okay? So positive and negative value of your reference angle plus k times 360. Same thing on this end, positive and negative value plus k times 360. So now from here I'm on the general solution method, right? Positive and negative value of your reference angle times k plus k times 360. K is a value of 0, 1, 2, 3, or well, minus 1, 0, 1, 2, 3. You're going to see we substitute values for that, right? But so far, this is what you do. Okay? You're all okay with this part, right? I'm telling you, I'll just add plus and minus of the reference angle plus k times 360. Right? So you're going to end up with 2 theta equal to positive 60 degrees plus k times 360, right? And 2 theta is equal to negative 60 degrees plus k times. Everybody still with me?
Yes.
Okay. Do the same thing here. You're going to end up with 2 theta is equal to 180 plus k times 360, and you're going to end up with 2 theta is equal to minus 180 plus k times 360. So don't do this method here. Okay, so now we got these general formulas. What you do is you start letting k equal to values of minus 1, 1, well, minus 1, 0, 1, 2, that sort of thing, right? And the angles you calculate must be within that range. So let's start with a value of minus 1. Okay, so you'll say let k equal to minus 1. So this becomes what? 2 theta is equal to 60 degrees plus minus 1 times 360. So 2 theta is equal to minus 1 times 360 is minus 360 plus 60 is 300 minus 300. Theta is equal to minus 150. Falls within our range. Okay, that's one value of theta. Then you'll say that's k equal to 0. So you'll say 2 theta is equal to 60 degrees plus 0 times 360. That's going to be 0. So theta is equal to 30 degrees. Still in our range. Cool, right? Let k equal to 1. Right? 2 theta is equal to 60 degrees plus 1 times 360. Right? So you're going to end up with 60 plus 360, which is 420. So you're going to get theta, 2 theta is equal to 420, and theta is equal to, but 210 is out of our limits. So not applicable. So we know we don't have to carry on the values of k because anything greater than 2 is going to be out of the range. And then if you had to put minus 2 into it, right? Minus 2 times 360 is minus 720, right? Minus 720 plus 60 is minus 660. Divided by 2 is the negative 330, already out of the range. So far, these are your values of x for this. You are understanding now? Yes? Okay. Here, you'll say, so these are your two. I'll never do it from this side. Right? So same thing over here. If I let k equal to minus 1, I'm going to get 2 theta equal to minus 60 degrees plus minus 1 times 360. 2 theta is equal to minus 360 minus 60 is minus 420, which is minus 210. Not applicable because of the range. If I let it equal to 0, I'm left with 2 theta is equal to minus 60 degrees plus 0 times 360. So theta is equal to minus 30 degrees. That's in our range. That's a good value, right? Then you get 2 theta is equal to, so we now be looking at that k equal to 1, right? Minus 60 plus 1 times 360, right? 1 times 360 is 360, minus 60 is 300. So theta is equal to, still in our range. Fine. So now we got minus 150, 30, minus 30, 150. All these values work. Okay? do the same thing. So it's not difficult, right? In your paper, you don't have to, I'm showing you each step because I want you to know it, right? You come here, right? You say 2 theta is equal to shift cos of half. You'll add your general solution part. It's plus minus that angle plus k times 360. And remember, k is a value of integer. It's minus 1, 0, 1. Right? You'll substitute. So all you need to say is let k equal to minus 1. Your angle is equal to negative 150. You don't have to show each step here. You just say your angle is equal to that, because you'll have just put it in your calculator. You'll have your standard thing 60 plus 1, 10. You go back and you calculate, change to 0, get a number. Go back, change to negative 1, get a number. Okay? I'm showing that so you'll all understand. Because the question is 7 marks. They want to know the values of theta. If we done it, we have only got 4 values. And even them to the values and then it wouldn't have worked. Right? So yeah, you would have said, okay, so now we let it equal to minus 1. So this would have been 2 theta is equal to 180 degrees plus minus 1 times 360. Minus 1 times 360 is? Minus 360 plus 180 minus 180, right? So theta is equal to minus 90 degrees. Let's calculate, right? Quickly calculate, you'll get that number, right? That's the value that falls within our range. Then you'll see 2 theta is equal to 180 degrees plus 0 times 360. Theta is equal to 90 degrees. If you try with 2 theta is equal to 180 plus 1 times 360, you're going to be left with theta equaling 2 theta is equal to 540, theta is equal to 270, which is not applicable. So your values for theta are using the general solution, right? Oh, I'm forgetting this thing. Right? Okay, you understand the method, right? So if I put minus 1 over here, I'm going to end up with theta equaling minus 540 divided by 2, which is minus 270, which is not applicable. If I let it equal to 0, I'm going to get theta equal to minus 180 divided by 2. You already got that there, right? And then theta is equal to positive 1 times 360 is 360. Minus 180 is 180. And then you get 90 degrees. Right? So wherever I got the arrow below it, it means that that's my answer. So you write down these values for theta that fall between this range. And you write it from left to right, like if you're drawing a graph, right? So it will be your general solution for theta is equal to minus 150 minus 90 minus 30 30 90 those are your values. If you want to double check it,
Oh, I just couldn't
I'm writing it neatly with all my values of theta. Right? You put those values into your calculator for wherever you see theta, it will give you 0. You'll see if you try to solve it with that other way, right? If you went from here and then you set shift cos, you get 180, cos is negative in the second and third, and you set 180 minus 180 plus, you'll have got values for it, right? The values doesn't work when you substitute it yet, because this is the method you use for general
Does
solution.
that mean we're doing it wrong all the time?
The examiner tests it very stupidly. Some questions, he'll do it like this. Then even the say even the same thing, right? Some questions you just go for it. But when you use this method, you will always get the right answer. Whether he marks it stupidly or whatever, you still get the right answer. So, what I need you all to remember, for sine and for cos, you add k times 360. Make a note of what I'm saying, right? For general and general, make a note. Somebody say general solution. For general solution for sine and cos, it's going to be your plus minus of your reference angle plus k times 360. Remember, my reference angle here is shift cos of 120. My reference angle is 60 degrees. Okay? And the only other thing is, for tan, it's plus minus your reference angle plus k times 180. That's the only thing I need you to remember, right? On all the past two papers where you got this, practice it with this method and see if you come to the same answer. You will. Okay? As you can see, it's not a difficult method, it's just that you'll solve it for the first time, right? Up until this point here is everything you've been doing. All I did was, when we come to this point here, you're going to get a reference angle, because how you get your reference angle is shift cos. And normally we say 2 theta is equal to 60 degrees, yes? Come on guys. Right? Shift cos, so 2 theta is equal to 60 degrees. All you do, you take the positive and negative, and you add k times 360 because we're looking at cos. You let k equal to value of integers. And then all you're basically doing is seeing if it fits in that range. Fits in your range? Good, perfect. Okay. This is the only other thing I think I needed to do with your. But even if you did your method, you would have found that you would have got like maybe 5 marks. You see earlier in the memo you got, right? The only thing they did, they left out that end of the calculation. I don't know why, don't ask me why. They left out this half of the calculation. Because they don't have 90 and minus 90. See the solution? I don't know why I would choose. But they got the 30. So if you looked at it and if you tried it and you checked the memo, you would have wondered to yourself, how the hell you got minus 150 and where's the other values? This is how the other values are.
Yeah, they put that here. They didn't put all the way.
So if you look at it, so this is how you would have done general solution. So remember, for your trig questions, when you are solving for if the theta was x or whatever, general solution. Okay? K times 360.
Yeah, they left out 90 and minus 90.
But you see, if you put it in your calculation, if you put 2 cos squared 2 times minus 150, minus 90, 30, whatever, plus cos 2 times whichever number we use, minus 1, all will give you 0. Yeah, I feel better now that I know you all know that. But I never took your for cheap. I took your tail end for cheap. I just came to see guys, these are your rules. These are your rules. Okay. So when you're doing your past year papers, use this method. Get to all your numbers. Even if the memo doesn't have the numbers, put your numbers. You take the numbers you worked out, put it in this equation. If it gives you 0, you did the right thing. Okay? You already started. That's it. That's good. Yeah, finish this cheek. Take a 10-minute break to breathe, get out of thoughts. Finish the paper, and then I can go home.
What are you doing next today?
Yeah, always when it comes to work.
The science you're gonna go home and attempt it. Then we look at it.
You see, so chemistry not there.
You see, even the maths will be better if you attempt it, because you're in non-way or what? Stuck. Nah. Yeah, don't like talking to me when I teach you something.
These are not great.
Okay.
We'll be making on 0 points.
basically.
So it's like instead of 0 points, we go for this general.
K times 360.
Yes, you need to write 2 points. And then this picture. Right of it. Can you guys get out the picture?
Yeah.
Can you get it?
Yeah.
Okay, because look at differentiation and sweep integration. Okay, 6.4. I want you to prove that cos, not 6.4, 3.4. I want you to prove that cos of 60 degrees minus 45 is equal to root 2 plus root 6 all over 4. How would you do this? You writing the exam, sitting there, okay. What you do?
Special inverse.
Special items. So,
But
Cos is equal to
if I say
cos
cos 60 times cos 45
No, you're gonna say
minus
cos
4 plus sin.
What's that one?
Cos of 60 times
All
compound.
compound angles, right? So first thing you need to do, you can't just put special angle for 60 and 45 and subtract it and think you're going to get to that. It's not that. This is cos of A minus B. Okay? So you need to use compound angles. Okay, so first things first, you need to choose a left hand side. Remember I told you when they say prove that this is equal to that, you choose one of the sides, you work it up and you get it to equal to the other side. Unless you have to solve for both and make it equal to one term. Right? Most of the time, but they already have a simplified term. You need to take the other end and make it equal to that. Okay, so we're taking our left hand side, right? Which is cos of 60 degrees minus 45. Adding your compound angle formula says that cos of 60 degrees times cos of 45 plus sine of 60 degrees. Right? Cos of 60 is, now you need to remember your special check.
See.
Because of 60.
1 over 2 times cos 45 plus sin 60. Sin 45? Right, so this becomes what? 1 over 2 root 2 plus root 3 over 2 root 2. Same basis, you can add the denominator. Right. Rationalize the denominator. So how would you rationalize the denominator? So remember that this is, if they asked you in general, solve for cos 60 minus 45, you're okay, it's okay to leave your answer like this. But now we're proving that it's equal to that. Is this equal to that? No, right? We need to get it in that form. So to get it in that form, you'll rationalize your denominator. How would you rationalize this? Times square root of 2 root 2, right? The whole thing, 2 root 2. Because if it was being added, then you'll multiply. If it was 2 plus root, if it was 2 plus root 2, you would have multiplied by root 2 over root 2. Because it's 2 root 2, you have to multiply by the whole thing. So if this here was 2 plus root 2, then you multiply by root 2 over root 2. But now because it's 2 times root 2, you'll multiply by 2 root 2 and 2 root 2. So this is 2 root 2 over 1 plus root 3 all over 2 root 2 times 2 root 2. Yes? So here you're left with 2 root 2 plus 2, and remember this is root 2 times root 3. Same surds. There? Where am I looking lost?
No.
Which part you lost?
you.
Which part you lost?
No, you're not lost. Still good.
They're still there, right?
Multiplying.
So this 2, root 2 is being multiplied by root 3, right? So this 2 is from here, right? And then the root 2 times root 3 is root 6, right? Because they both are under the same surd. So you just take that number 2 times 3 all over. 2 and 2 is 4. Root 2 times root 2 is root 4. But root 4 is 2, right? So 2 times 2 is 4. Yes, yeah. It's supposed to become 2 root 2 times 2 root 2 is 4 times 4.
4 times
8.
8, yeah.
It's 8.
4 times 2.
Yeah.
7 plus 4.
Because it's the same numbers under the.
Yeah, it's 8.
It's 8, right? And if you see, you put root 2 times root 3, you calculate it, you get root 6. Not 2 root 2, just put root 2 there, yeah. So this here is 8, right? Because 2 times 2 is 4, leave that one side, right?
Yeah.
And then root 2. Oh, I was right, man. I've seen the right thing so long. Yeah, so it's 4 times, and then root 2 times root 2 is what? Root 4. Root 4 is 2. So it's 2 times 4, which is 8. Yeah, okay, so we're back on that. Right. Good. To simplify this, remember it's the same as saying 2 root 2 over 8 plus 2 root 6 over 8. So 2 over 8 is 1 over 4, which is root 2 over 4, right? And then plus, and then 2 root 6 is the same as saying 1 over 4 again, right? Or root 6 over 4. And then isn't that equal to that? So it's equal to your and in fact here we confused over
The last part.
When you come to that part, you're not writing out fully, right? Because remember, when you multiply these two things out, 2 times 2 is 4. And then it's not like multiplying 2 into 2 and 2 into root 2. Right? This is just 2 factors, right? So this is 2 times 2, which is 4. Root 2 times root 2 is root 4. Root 4 is 2. So the 4 times 2 is 8. That's how you come to it. Or, this is a better method, right? See when you hear, just put it in your calculator and the calculator will tell you 8. Okay? Here, because it's being multiplied into the plus sign, you have to multiply each one.
And the last part, 2 plus root 6, I get.
How I came here. Right? Remember, this here is the same thing as saying 2 root 2 over 8 plus 2 root 6 over 8. And remember that 2 over 8 is 1 over 4, which is the same as saying root 2 over 4. And then plus root 6 over 4. So, same denominator. Are we okay? Okay? So we've got 60 marks in our paper. Okay, jokes aside, right? From the first question till now, the only thing that you would have had an issue with is the general solution 1, right? But you would have still got 5 marks for the question because in the method you use, you would have still solved for 30 and 150 degrees. So you're still sitting good, right? Anything else in the thing we did from question 1 to question 3 I never did with you? Okay, that wasn't but the Cramer's rule 1 was the problem with the Cramer's rule 1 is everybody thinks that it's x is equal to dx over d. It's that function is equal to the determinant of the function over the determinant of the whole set. That's the thing. But either everything else, you leave those aside. We did it, right? Let's take a 5-10 minute breather, gather our thoughts. Now come back, we'll put a smile on our face. We'll do this, finish it. Next one is differentiation and integration, so that's too easy for you all.
No, we didn't practice with that now. We didn't practice.
So, question 4. Right, question 4.1. They want you to determine the following limit where you have the limits as x approaches 4 for square root of x minus 2 all over x minus 4. Right? And normally with the limits, you'd substitute that limit that they give you. But if you substitute square root of 4, which is? What's the square root of 4? 2. 2 minus 2 is 0. And in the bottom, 4 minus 4 is 0. So this is limit with the form of 0 over 0. And what we do then? You factorize to get rid of the terms that give you 0. Now, how do you factorize it?
Let's see.
Some of you may use binomial theorem on the top, some of you may try to factorize. But how do you factorize something like this? Remember, we get something called difference of two squares. You get, if it was x squared minus 4, it would have been x minus 4, x plus 4, right? Difference of two squares. If it was x squared minus 4, you would have had x minus 4. Or if it was, sorry, if this x minus 2 and that, right? Cause x squared, then minus 2x plus 2x will cancel and you're left with minus 4. Now you got x minus 4. This is sort of something called difference of two roots. Okay? So, if I said here root x minus 2 root x plus 2. What is this going to give me? Right? This would have gave me, remember the surd times the surd is the same as x to the power half times x to the power half. Same basis, you add the indices, right? Half plus half is 1. So this multiplied by this, it's the same thing as saying x to the half minus 2 times x to the half plus 2, which is x. And then these two middle terms will cancel, right? Because you end up with minus 2x to the half plus 2x to the half. And then you're left with, okay? So here, it's the limit as x approaches 4 for square root of x minus 2 over square root of x minus 2 times square root of x plus 2. We only factored. Yeah, because why we did that is because we can cancel these two. The two terms that give you 0. So cancel, cancel, you're left with the limit as x approaches 4 of 1 over square root of 4 plus 2, or square root of x plus 2. Then you would substitute. It will be 1 over square root of 4 plus 2, which is 1 over 4. That's it. Okay? This is them testing your application. Even that determinants one. So now you haven't been taught, it was them testing your application. Okay? So this is our, you'll remember the part where it's limits of 0 over 0. So you need to try and factorize to get rid of the terms. So how you would factorize this, but we don't do that often, so that's why maybe I wouldn't have thought about it, right? So this here is like a difference of 2 roots in 10 minutes, right? Teaching them. Okay. So this is this. And okay. Let me do question 4.2. I'm taking it the second we'll see it here, right? Okay. 4.2. Differentiate with respect to x, y is equal to tan x over ln of x with the aid of the quotient rule. Now, what is your quotient rule? Your quotient rule says that dy over dx is equal to v times du over dx minus u times dv over dx all over a squared. All agree? That's the rule for quotient, right? If you're looking at this, this here is your u, this here is your v, right? So when you're doing dy over dx, it's going to be equal to ln of x times the derivative of tan x minus tan x times the derivative of ln of x all over ln of x squared. Yes? Everything is, you know this, right? So, dy over dx is equal to ln of x. What's the derivative of tan x?
Tan x is sec squared x.
Sec squared x. Sec squared x minus tan x, derivative of ln of x.
It's 1 over x.
1 over x, right? In that instance, k is 1. Like, remember I told you they don't show each one, they show the other one. Okay? So this is 1 over x all over ln of x squared. That is your answer. Because you can't simplify it any further because there's different terms, nothing is going to cancel with the ln of x squared. Because remember, this is being subtracted. Even if you multiply, you can't cancel it because it's different terms. So this is your answer. You have gotten a mark for giving the derivative of this, the derivative of that, for using the quotient rule. It's only 3 marks. Not bad. You all know this. Some of you are looking at you don't know this.
We know it. We
don't know this, right?
Confident in
4.3.
practice.
They ask you to differentiate with respect to x, y is equal to ln of x squared, ln of x all squared, with the aid of the product rule. Now remember something, okay? What is this? These two that they gave us. ln of x squared, right? Okay, I'm writing square brackets, right? It's that being multiplied by that. Agree? This is ln of x squared. ln of x squared. This here is this whole function squared. There's a difference. Can you see the difference? Okay? Can you see the difference? So what is that? It's a function of a function, right? One function here is ln of the bracket. The other function is x squared. Here, the other one function is that bracket squared, or the x to the power n, and the other function is ln of x. Okay, functions of functions. Okay? They want you to use the product rule to solve for this. Product rule states that dy y over dx is equal to u times dv over dx plus v times du over dx. Yes?
Yes.
Right. So, in this instance here, this term here is u, this term here is v. So, u is ln of x squared times d over dx of ln of x squared. No, ln of x squared, right? X squared. Can you see on me? Remember that steps? Yeah. Okay. Plus v is ln of x squared times d over dx of ln of anybody confused so far? I want you to just look at it and see what I did.
In the formula sheets,
They don't give you the functions of functions.
this one, 2y plus x plus u times in brackets x.
Oh, for the formula for the thing, the way they wrote it.
So the x is d over dx.
So the way they wrote it is, what's up? dy over dx is equal to u of x times b, that's supposed to be prime, x plus u prime x times b of x, right? And remember, above that they showed you for an equation of u x times vx. That's the same thing as saying f of x and g of x. Function of x, right? So remember with the product rule, you leave one function the same, you derive the other. Plus, you derive the other function and you leave the other one the same. It's the same thing as that. Okay, so okay, yeah, get used to that, right? But here, so far we did this, right?
Yeah.
And I'm showing you that it's functions of functions. Same thing, you would have seen it as ln x squared, ln of x. You see where the 2's are, right? When they gave it to you with the 2 there. Because they're basically referring to the whole function being squared. Like how when we say cos squared x. We don't say cos x, close the bracket squared, we say cos squared x. Right?
Yeah.
So that's what we got. Right. So this here is, well, it will stay the same, which is ln of x squared, because this is just the function. Yeah? The derivative of this is what? This is, if you go back to your rules in your textbook. Right? You know the page where they had rule 1 to 25? Right? Which page is that?
211.
211, right? This is f of x to the power n. You all agree with me? It's a function to the power n.
Yes.
Yes? Everybody? It's f of x to the power n. F of x is ln of x. And ln of x is to the power 2. 2 is n. So which rule over there says f of x to the power n? 16. And how do you do that?
And
F of x, n minus
oh, and
Minus 1.
Right?
F of x, n minus 1 times d over x, f.
So you take your function to the power n minus 1. The first thing you take is it not n f of x to the power?
Yeah,
It's n f of x to the
Yeah.
power, right? So this here is 2 f of x is ln of x to the power n minus 1, which is 2 minus 1, which is 1, right? So we don't have to write that. Okay? Times, what's the rest of it?
d over dx, f times f of x.
10 f of x. So they're telling you to derive the function part, the derived ln of x. Ln of x, the derivative of ln of x is 1 over x. So this here is 1 over x. Right?
Okay.
Anybody confused? So I'm going to make a note here that this is rule 16. For carry on, anybody confused? Fine, right? It's function of a function. You need to be able to see what type of function it is. Okay? Plus, this will remain the same, right? ln of x squared. Then they want,
The 1 over x is rule 7.
no, it's part of, yeah, well, it's, because remember then it's just ln of x, it's ln, that function is ln of x. So to derive ln of x is rule 7.
Yeah.
But I'm saying to, how I got this whole portion was with rule 16. Rule 16 states that f of x to the power n is equal to n of f of x to the power n plus
minus
n minus 1 times the derivative of that function. All with me there? Okay. If you're looking at this, remember how I told you this is f of x to the power n? Right? How would you call this function? Or what would you call this? Like how I told you, ln of x all squared is f of x to the power n. Looking at that, how would you tell me?
Oh, it's ln of. Yeah, but it sounds the same.
Say it.
X to the power n. No, it's not the same. But I'm saying it sounds the same. You said the side is ln of x to the power n.
ln of x all to the power 2.
This side is the ln of just the x to the power 2, not the whole thing.
Right. So like how I said here, that ln of x all squared is f of x, the function, because the function there is ln of x. And the other function is to the power n. So I said there it was f of x to the power n. How would you say the other side?
Is f of x squared.
What else?
And because the ln of x is a function of a function. It's ln of x, then there's root of x squared.
Right? Put it together. Yeah, that's what I was saying. Okay, see here, right? This is d over dx of ln of x all squared. Yes? Yes. Let's say let ln of x equal to u. Eh? So when I'm writing the two functions that are here, those two functions are u equal to ln of x, right? And the other function is u squared, right? So it's this function that's in this function, right? And f of x is function of x. Which one has the function of x? Ln of x. So I can call this the function of x, right? And if I put it back there, I've got the function of x squared. Squared is the same thing as to the n, right? So that's how you knew to go to rule 16, because it's the function of x all to the power n. Now if you're looking at this, right? This is ln of x squared. So if I say let u equal to x squared, then one function is let u equal to x squared, right? That's one function. Alright, yeah. That's one function. And then the other function is u, right? ln of u. Which one has the one with the x? So this is f of x, right? So the same thing is in u is equal to f of x. So here it's ln of f of x. So which rule would you go to?
Rule 1. Oh, but now rule ln, that's the thing.
Listen to what I'm saying.
Squared is rule 1.
ln of f of x. Go to your rules. Which rule says ln of f of x? 25. Go to 25. Remember something, guys. From rule 16 to 25, which rules are those? People will think I never taught it.
Differentiation.
From rule 1 to 15 is your standard differentiation, right? It's only with respect to x, just x. Rule 16 to 25 is when we have functions of functions, where they use the chain rule to derive this. So if I'm telling you ln of a function, ln of something is one function, x squared is another function. So you know you need to be looking at rule 16 to 25. So when I say ln of f of x, that means I'm asking you for the natural logarithm of a function. So you need to go to rule 16 to 25. So which one looks like that? It's rule number 25. Do you understand what I'm saying?
Yeah.
I need to practice more differentiation, right? So what does that rule say?
1 over f of x.
1 over f of x. So they're talking about here 1 over x squared. Huh? ln of x squared. F of x is x squared.
Times d over dx times f of x.
So it's times the derivative of f of x. F of x is x squared. What's the derivative of x squared?
2x.
2x. So this is 2x. And this is rule number. That's your answer. That whole thing is your answer. Okay? because you don't need to simplify it further, because all of these terms you're going to end up with ln of x squared times 2 ln of x times 1 over x plus ln of x all squared times 1 over x squared times 2x. It's all different terms, right? So this is your answer, right? Remember, I can see I'm having an issue with this part here, right?
This one is not in the formula sheet.
Yeah, they don't give you the chain rule ones in the formula sheet, right? See, remember when we did chain rule, right? When we did, if they asked you for d over dx of ln of x all squared, right? You can see that your function, it's a function of a function. It's a function of ln of x
Yeah.
to the power 2. That's x to the power n. That's another function, right? Remember when we did, this is me doing chain rule, how I taught chain rule, right? You let u equal to what? Why you let it equal to ln of x? You let it equal to the function that's with respect to x, right? So the function that's with respect to x is ln of x, and you introduce your derivative on both sides. You remember this?
Yeah.
So it's du over dx of ln of x. The derivative of ln, this is not a function of a function, it's just one function, ln of x, which is 1 over x.
Yeah.
Now because we let u equal, if u is equal to ln of x, then let's say this is y is equal to, then y is equal to u squared, right? Yeah, this is what the equation is, right? Y is equal to ln of x squared. And I want you to differentiate it. So you know it's a function of a function, you use chain rule, came there, now we're here, right? To differentiate, okay, so you introduce your differentiation on both sides, because you're differentiating with respect to x. Yeah, that's right.
Yeah.
So this is d over dx of u squared. Right? So this is dy over dx is equal to the differentiation of this. No, sorry, I lied. This is differentiating between with respect to u. Right? Do you remember? Because I told you, you differentiate with respect to the independent variable. So I'm differentiating equation y with respect to u. Are you remembering this?
Yes.
Right? So u squared is the same as saying x to the power n. Right? And that's what? It's 2u.
Yeah.
Now chain rule says that the differentiation of y over x is equal to dy over du times du over dx, chain rule. Dy over du is 2u times du over dx is 1 over x. But remember that u will let it equal to, so this is 2 ln of x times 1 over x. So the differentiation of ln of x squared, the function of the function, is 2 ln of x times 1 over x. And remember when we did, after we did chain rule, I told you that they came up with formulas because doing the substitution method is long.
Yeah.
Right? They came up with those rules. And if you look at this, and if you look at
16.
yeah,
That's not.
this one, if you look at this, is it not the same thing?
Same
It's the same thing. Eh? That's the longer method of deriving the function of a function. That's why they came up with the rules. And how you use the rules is, the rule 16 says that differentiation d over dx of rule 16 is of f of x to the power n, right, is equal to n of f of x to the power n minus 1 times the derivative of f of x, right? So if you're taking the differentiation of ln of x to the power 2, it's 2 f of x is ln of x. It's ln of x to the power 2 minus 1 times, you're deriving now ln of x. So here it's going to become 2 ln of x to the power 1, right? And then the derivative of ln of x is, so this is using the chain rule, and then this is using the shorter formula of how they got to that.
So if you can't remember the formula, use the chain.
The formula is in the, oh no, yeah. That's where, because they give you the chain rule. See, dy over dx is equal to dy over du times
Yeah.
du, yeah. So if you can't, on the side of your page, just work it out
Figure
quickly.
it out, yeah. At least
Function,
once
of a
you get to single function, you can refer to your formula sheet.
because the formula sheet will have for all your single functions.
Yeah.
If it's just in terms of x, if it's not
So we have
2x or still worried now that you've got
You can't get 100% on this one.
no, but still.
But then if you work it out, it makes sense.
No, I know.
You can work it out. If they give you the formula to work it out.
Let's go over this one. Let's go over this one.
Very, very good.
Rest it
So I did this round. Remember, I think it was only 1 to Kaya, the kid.
Oh,
Temba, I think.
it's 4 of us.
The recording on chain rule, product rule, and quotient rule is, it was all done in one lesson.
Yeah.
So Ish, I think you watched it because you were also absent. You watched it and you came in the next day.
But also like every night, like playing up with this stuff.
The moment you identify that it's a function of a function, then you go and do it. Okay guys, you got the picture, right? Can I check out the side?
Yeah.
10 plus 10. College 12.
Can I take
What a past 12. Please practice guys. When you go home, try to practice doing d over dx of ln of x squared. That will be, if y is equal to ln and the function is x squared, do the chain rule and see if you come to the same thing. Because if you can do the substitution method of the chain rule, you'll understand how to use the rules of it. Remember we did it all with chain rule, then we did some examples where we used the short form. Right? Okay. Can I check out? Okay. Now they want you to differentiate with respect to x. Y is equal to 1 over cosec 3x minus 1 over cot x plus root 2 over e to the minus x minus 6 to the power 2x plus 2 pi over p. They want you to differentiate this, right? So they want dy with respect to x. You're deriving equation y with respect to x, so you must leave your terms that come out in with x in it, right? So you are deriving d over dx of 1 over cosec 3x minus 1 over cot x plus root 2 over e to the minus x minus 6 to x plus 2 pi over p, right? And remember with this, you'll derive each term. So you're taking d over dx of 1 over cosec 3x minus d over dx of 1 over cot x plus d over dx of root 2 over e to the minus x minus d over dx of 6 to the power 2x plus d over dx of 2 pi over p. Right? Right. So before we start deriving and just going into it, 1 over cosec is what?
Sine.
Sine.
Yeah.
Sine 3x it would be, right? Because remember, if you go to your thing, you don't have anything of 1 over cosec, right? So this is the derivative of sine 3x. And what is this?
Function of a function.
Function of a function. It's sine of that. 3x is a function. Sine of something is a function. So you'll be using the chain rule formulas to get this one. Move on. D over dx. 1 over cot x is what? Tan. This is the derivative of tan x. This is just a function. It's only x. Right? Plus. So you'll take out your constant here. Root 2 over dx. But remember e to the minus x. 1 over e to the minus x. 1 over e to the minus x is what? If I asked you 1 over x to the minus 2, what is this? It's? So what's that? 1 over e to the minus x. It's e to the power x. Minus d over dx, 6 to the power 2x. You can't do anything about it. That's a to the power 2x. That's a function of a function as well. One function is 2x. The other function is a to the power x. This here is a constant, 2 pi over p. P is a constant value. It's not with relation to x. There's no equation for it. P is equal to this here. It's taken as a constant. Derivative of a constant is what? So that's done. Right? So far, is there anything that we're confused about? Right? Now, let's go. The derivative of sine of 3x is what?
Cos.
You can never listen to me. What is that? It's sine of f of x, isn't it? So which rule you're looking at? 17. Sine of 3x, sine of f of x. Right? Says that it's f of x
That's cos f of x times.
cos f of x times d over dx of f of x. So it's cos of f of x, which is 3x, times the derivative of 3x, which is what? 3. So I can write this 3 in the front, right, as 3 times cos 3x. You understand this? You have said this is rule number?
17.
Right. Minus the derivative of tan. This is just tan x. It's not a function of a function, there's only x. It's not tan of x squared, sec squared. So this is sec squared x plus the derivative of e to the power x is e to the x. So this is root 2 e to the x minus. This is a function of a function. So if you're looking, what would you be looking for? If you're looking in your rules, what you're looking for that looks similar to it? Or what would you be looking for? What is that? That's a to the power f of x. It's to the power of a function. So which rule in that rule 1 to 25 is a to the power f of x?
24.
24. And what does it say?
It's equal to a to the power f of x
So it's firstly it's a to the power f of x times ln of a times the derivative of f of x. The derivative of 2x is 2, right? So it's 6 to the power 2x times ln of 6 times 2. Yes? And then plus 0. So this here is your answer. Now then you need to go back and go over all this stuff, right?
Yeah. Let's take the videos.
Yeah, when I say go over past your papers, do examples. I'm not taking for nothing. You have to. Right? That was question 4.4. Question 4.5, they want you to calculate with the aid of differentiation, calculate the x coordinate to the point of inflection. So I can take it over, right? So 4.5, you are given f of x is equal to 3x cubed plus 9x squared plus 3x plus 7. They want the x coordinates of your point of inflection. Point of inflection, second derivative equal to 0. So this is f of x. F prime x is your first derivative, would be what?
9x
plus 18x plus 3.
That's
0,
your second derivative is
18x plus 18.
that's it. Right? So for point of inflection, your second derivative you let it equal to 0. So you let 18x plus 18 equal to 0. So 18x is equal to negative 18, x is equal to negative 1. Right? And they asked you for only the x coordinate of the point of inflection. Yeah. They only wanted the x coordinate. If they wanted the coordinates of the point of inflection, what should have done? You substitute that minus 1 into 3x cubed plus 9x squared plus 3x plus 7.
And it's 5 marks.
4 marks.
4 marks.
4 marks.
That's what I'm sure you know. You remember that, right? Yeah, really need to practice, guys. No, for real, like you'll need to go back and practice. You'll need to watch the videos, do more examples. The only way you're gonna get used to it is if you do it. You'll get used to using these things, looking at it and saying, okay, this is a function of a function. It's not just a function. This is a function. It's only in terms of x. This is a function of a function because sine of x would have been a function. 3 of x is another function. Get what I'm saying? Okay? Where else we have functions of functions? Here. 6 to the x is a function. 2x is also a function. So when it's 6 to the power 2x, it's a function of a function. And you use chain rules. Right?
Maybe another way to remember is if you don't have it on the first 15.
If you can't find it on the rules they give you, you know it's a chain rule. Right? Because remember how you look for these things is like here you would have said, okay, this is too straightforward. You would have like if you had x cubed, right? You know that this is x to the power n. So when you go into your derivative rules, you're going to look for which one says the derivative of x to the power n. Same thing of if it was ln of x, you know that you need to go to the rule that looks like ln of x. If this was now x plus 1 cubed, that's a function to the power n. So you know for your rules, you need to go look at the one that has function to the power n. Need to get used to them, yes. Can I take this out?
No.
Yeah.
So, okay, so how many marks do you think we would have got for differentiation? No, the point of reflection?
That's not really. Not get answers to really.
Hey, come on. It's only for me.
No, as I said, we need to practice this one. This one we just learned now, so we need to.
You know, we're interested now. We're investing.
But in these 5 questions we did, is there anything you didn't teach you?
You told me.
Right? So you'll know it. Matter of practicing.
Yeah.
Only way you're gonna get it, right? Taking it out, right?
Okay.
Question 5. Question 5 is integration questions. They want you to evaluate the following integral. So you are evaluating that equation with respect to t. How would you do it? Remember you got your limits, your upper and lower limits, right? So what's the first thing you do?
T squared.
You will integrate the function, right? So you're integrating this function, you're integrating t squared first. Integration, the integral of t squared is, go to your data sheet in the paper that I gave you.
It's 2.
It's x to the power n plus 1 all over n plus 1. Is it there?
No.
Yes, it is. Right in the bottom, below the differentiation table, the integral of ax to the power n dx is equal to ax to the power n plus 1 over n plus 1 plus c. Right? Stay on the page. Right? So, this here is going to become what? T cubed all over 3. Agreed? Plus 2t would become what?
It's 2 t plus 1, so it's 2t over 2.
You remember this is 2t to the power 1.
T4 over 4.
So,
No, no.
No.
When 1 plus 1, 2t.
yeah, this year I can't say anything because I did this week. I did this on Monday.
2t over 2.
Yeah,
It's 2t squared over 2.
Excellent.
The n on the top needs to match the n on the bottom,
Yeah.
right? Plus, remember when we did the differential of 1? Remember, I mean, integral of 1. Remember I said it's not like differentiation where a constant will disappear. The constant will bring that term back because it's the opposite of differentiation. Remember when we did the integral of dx, we said was x, right? So the integral of this would be, remember this is 1, it's x, okay, in this instance it would be t to the power 0 plus 1 all over 0 plus 1, which is t. So this is t, and you're integrating from 0 to 1. So if you plus c, exactly, good. Don't forget plus c, right? So this is t cubed over 3, that and that will cancel, right? Plus t squared plus t plus c integrating from 0 to 1. So now we got it, right? So now what you do? Substitute your upper limit and subtract it from your lower limit. So here you're going to end up with 1 cubed over 3 plus 1 squared plus 1 plus c minus 0 cubed over 3 plus 0 squared plus 0 plus c. 1 cubed is 1 over 3, which is 1 over 3. 1 squared is 1 plus 1 plus c minus 0 cubed is it's 0. 0, 0. So you just have to minus c. 1 plus 1 is 2.
2 plus
2 and yeah, it's 2 and 1 third, right? Which is 2.333. Yeah. That's your answer. And remember this. Jeez, what? We did this yesterday.
Wednesday. No,
I started integration on Monday.
yesterday.
Yesterday I did definite integrals.
Yeah, but
Yesterday.
Probably been doing all the other stuff. Recapping all this other stuff. So then,
practice.
yeah.
Okay.
Practice.
5.1.2 is the integral of sine 2 theta all over cos theta d theta. So you're integrating that with respect to theta. How you do it? Why are you flipping pages? what are you looking for? Look at it. Failure as a teacher. I've not done enough. Okay, I'll give you a hint. Think of cheap stuff.
Okay, sine over cos is if I just put it. Okay, sine over cos is sine.
Let me stop you there. Right? Sine of 2 theta is different from 2 times sine theta.
Oh yeah.
Right?
Sine
Sine of 2 theta is a double angle. Yeah?
Yeah, it's sine.
And some of the when you break it down with double angles is that sine of 2 theta is 2 sine theta cos theta over cos theta. Yes? Cancel. You're integrating 2 sine theta with respect to theta. Constant, you can take it out. The integral of sine theta? Negative cos, right? So it's negative 2 cos. That's one. Now where you're turning pages and where you're going to find this, that when you had a plan, you knew what you were doing. You had your own plan, your own mission, you knew where you were going.
And they don't give us double
In the same.
formula.
In the formula sheet. I think they only give you what compound angles are. Compound angles, they give you some of that formula, that sine squared x plus cos squared x. They give you polar forms, converting exponential to log.
How they give you the ones that you actually need?
No.
Some of them you don't need it. They put it.
The only the integration one I noticed that they give you the ones that you're going to use. Because if you look at the integration we did, and if you look at the ones they gave you, it's only the ones that we're using. Okay? Okay, you got your picture, right? You can see. Right?
Oh yeah, for sure. Trick is everywhere.
Everywhere you can see. Hope they don't put it in the determinants or something.
They go answer.
Yeah, I don't know. They do what they want to.
If it gives you a value, then you put it. Please. Tell me to place X.
Right. Right. Yes. Right. Good. Right. The only thing I'm talking about, the integration of all these. right? How would you do it? You're sitting in this exam on Tuesday, looking at this question, what would you do? If you leave it blank, oh my god, I will make you write something over there before you leave. If you, yeah, right, thank you. Let's do each one. So you have to integrate 2x squared with respect to dx plus the integral of 3x to the minus 1 plus the integral of 4 tan x plus the this is all with respect to dx, right? Constant you can take it out, right? So you say 2 tan the integral of x to the minus 2 dx plus 3 times the integral of x to the minus 1 dx plus 4 times the integral of tan. I'm just writing it to show you every step, right? But you all would have just went from here to the next line number, right? 3 sec squared x dx, right? This is the integral of x to the power n, which is, so it's 2 times x to the power minus 2 plus 1 all over minus 2 plus 1 plus 3 times x to the power minus 1. Remember, x to the minus 1 is what?
1 over x.
Remember on Monday we did
Yeah.
e to the x, and 1 over x. Yes? So what does that come to when you integrate it? Please my data sheet. Yes, yes. Go to your data sheet.
A over x.
A over x.
And then a ln of x.
Right? But okay, because I took out the constant, we just write it as 1 ln of x. So it's just ln of x. Right? Plus. You're with me, right? Remember integration will give you the ones you're going to need. Right? 4 times integral of tan x. Integral of sec squared x.
10x is ln of
Sec x.
sec x. Ln of sec x. According to the data sheet.
ln of sec
Data sheet.
Plus 10x.
sec x plus tan x all squared. Because remember that's sec squared x. Yes? Plus c. So this was supposed to be 3 times. That agree?
We can do that.
See the 4.
Yeah. Because remember, see where this 2 is.
Yeah.
It's the
Oh,
same
it's
as
not-
saying
One square.
this is not differentiation, functions or functions and all that. This is integration.
Integration of tan x.
Yeah.
Formula sheet it says it's ln
So why you told me sec
Oh,
squared?
sorry, that was me.
ln of
Oh, dx. Okay.
So this is
Yeah, that was sec x.
ln of sec x.
yeah.
Right? That's right. Okay, it's actually not the end of your answer. You would have wrote it as I forgot about this part. I was being mistake. So this is 2x to the power minus 1 all over minus 1, which I can write as minus 2 over x. Remember it's x to the minus 1, which brings it to x, plus 3 ln of x plus 4 ln of sec x plus 3 ln of sec x plus tan x squared plus. So that is the integral of. Oh, why am I taking that? Yeah. Right? Last question. So far, how many marks were the bad vouchers? Exam.
40%.
About we 4 marks, so we were at about 96%. No, 8 marks. We were at 92%. Is it?
Hey,
Yeah?
it's not make sure.
91%. We were at 91%. Now we're trying to chalk this paper now, right? So you're going to picture that? Let's do this last one.
Okay.
I'm gonna be very sad if I don't know how to do this one. I'll do it like less than 24 hours to go with you. Right? This is now. We are looking at question 5.3.1. Sketch the graph of x is equal to y squared and clearly indicate the area included between x equal to y squared and the x-axis x between 0 and y between 2. There? Okay. So, when we did this question yesterday, what's the first thing you do? You draw a graph, eh? So this is x is equal to y squared. What graph is this? Parabola, right? But this is the sideways one because remember your x and y is inverted. Remember that, right? So if we draw it, we don't even need to work out the intercepts because we know that the graph would look like a C that passes through 0. You agree? Right? X is 2 and then x is equal to y squared. They want to know from 0 to y equal to 2 what's the area. So they want to know that area. Also agree? So then we need to draw that rectangle strip, right? But its length is now x and its breadth is now. Remember the yesterday's one we were doing, it was the breadth was dx and the length was y. That's slightly different. Okay? So, what they ask you? Okay, the next one that they ask you to do, calculate the magnitude of the indicated area in question 5.3.1 with the aid of integration. Right? So, this is the graph. Remember, yesterday we said dA, the area now, will be equal to length breadth. dA is now equal to, the length is x dy times dy. But so now we're differentiating with respect to y. Yes? Can we differentiate x with respect to y? I mean, no, sorry, not differentiating. We integrate. So you introduce your integral here, right? dA integral of dx dy, right? And then you get a is equal to the integral of x with respect to y. Can we integrate x and end up with y terms the way it is?
No.
No. What you need to do?
Oh my god. Oh, so right there is x is
The equation, right? Because the equation is in terms of y. So this here is equal to integral of y squared dy. And you integrating from 0 to 2. Integral of y squared will be what?
over
3. Right? It's going to be y cubed over 3. And you are integrating from 0 to 2. And then you're going to substitute your upper and lower limits, right? So you're going to get 2 cubed over 3 minus 0 cubed over 3. 2 cubed is 8 over 3 minus 0. So it's 8 over 3 units
time to practice this one.
Yeah.
Because we just did it.
I did yesterday.